Lesson 4, Basic Lighting. To follow along with this lesson, you will need the code and setup from OpenGL Lesson 1. We explained the local illumination model in an algorithms video on 3D graphics. In that video, we discussed the ambient, diffuse, and specular components and the type of lighting effects that each models. In this lesson, we are going to give a simple lighting example which illustrates how to use the local illumination model to light an object in OpenGL. We start with our OpenGL Lesson 1 project code and make modifications to it. To begin, we change the initialization function. First, we set the GL orthogonal arguments to -1 here and here. This statement sets our viewing volume, which is now the box shown here, from -1 to 1 in x, y, and z coordinates. Then we add these lines to set the lighting model, enable lighting, and enable a specific light. The first line sets the lighting model to a local viewer. This will be explained in depth later. The second line enables lighting, and the third line enables the light number 0. OpenGL allows for multiple light sources, but we will only use one now. Next, we add these lines to define the ambient, diffuse, and specular components of our light source. The four-dimensional arrays for each component represent the red, green, blue, and alpha channels of a light source respectively. We will almost always leave the alpha channel value as 1 and set the red, green, and blue channels equal to each other. Having all the color channels equal means that the light source is white, which is typical for most situations. Here we have set the color channels to 0.2 for ambient light and 0.8 for diffuse light. Generally, it is best to have the diffuse and ambient light components summed to 1. Finally, we add these last two lines to the initialize function to set the light's position. The first three entries of the position array are the x, y, and z coordinates, respectively. The fourth coordinate will be explained later, but it should almost always be set to 1. Notice that the same function call was used to set the light's components and to set the light's position. The first argument to the call tells which light to set. The second argument tells which property to set. The third argument tells what value to set the property to. In the draw function, we remove these 5 lines of drawing code and replace them with this code. The first block of the code defines the properties of the material that we are going to be drawing with. This replaces the color setting that we had before with a more sophisticated specification. Incidentally, this code is available for download from our website, zoax.net. The GL material function calls set the reflectivity of the material. Notice that we have set the ambient diffuse terms to the color of the material, which is taken to be green here. The specular color is set to white, which is typical as we stated in our lesson on local illumination. The shininess is set to 60, but can be set to anything from 0 to 128. This last section of code is where we do all the drawing. This draws a single square from -0.9 to 0.9 in both the x and y directions. However, the square is drawn as many little squares with a side length of 0.01. The reason that we draw this as many little squares is that the light over a single square is relatively constant. We will explain this more when we talk about shading. To calculate the light for a polygon, we need to specify its normal vector. The normal vector in this case points in the positive z direction for all of our squares, so we only need to specify it once. If we execute the program, we see a green square with ambient, diffuse, and specular reflections. Here's what each component looks like separately. To get a better sense of what is going on, we will look at the situation as an outside observer and add some context to it. This image shows the bounding box defined by our GL ortho call, as well as the green square that we drew. The red sphere shows the position which we are viewing from, and the white sphere is the position of the light source. This view from the side shows where the viewer and light source are in relation to the square. The viewer and light source are in the plane z equals 0, while the green square is in the plane z equals -0.2. The viewing direction is toward -z. Here are a few more images to give you a better idea of what is going on. This concludes the lesson.